Hello, class. This is an experiment I want to try in the 3D printing class. Um, One of the things I want to do here is I would like to go into McMaster Card Catalog, and I'm going to find the IGES file. I'm going to bring the IGES file into Inventor, and I'm going to convert it to an IPT file. And then once I convert it to an IPT file, I'm going to save export it as a STL file. And see if we can print it. Now I'm going to use an example of a screw or a bolt. You might find something else. You might want to print a gear or something like that. So there's a variety of things that you could bring in. We just have to make sure that we're not going to waste a lot of ABS plastic in doing so. All right, so to get started, I'm going to go ahead and go into Google Chrome. And I want to bring up McMaster Card Catalog. So you type in McMaster. Got to spell it right. So here's the link. And I'm just going to go ahead and go to screws and bolts. Okay. And I'm going to use inch, system measurement inch. The thread size, I'm going to select maybe a 1/2 inch 20. So that's 1/2 inch diameter, 20 threads per inch. Okay, the length of this, maybe make it 1 inch, and we'll call it a socket head or use a socket head. We're not going to be worried about material, but you can just go ahead and select a material. I'll just go ahead and select the steel, fully threaded, black oxide. All right, so standard. All right, so anyway, you get to something that looks like this, right? You see a little symbol right there that means they have CAD data for that particular part. And I'm going to click on the product detail here. All right, so this is what the screw looks like. This is all the specifications. Here is a drawing of the part, which you could download that as well. But you come in here and you're going to select 3D IGES and you're going to download it. All right, so it comes down here, and Mr. Morris wants to go check and see what folder it's in. And I can see that it's in PC, Windows, User, Morris, Downloads. So I have to remember the pathway, okay, or the directories here, right? So it's there. Right there's the screw. You can see I did it once before here. This is actually an STL file here. This is not. All right, so I'm going to show you how to do this. All right, so there's the IGES file. I'm going to minimize this. I'm going to go into Inventor. Okay, and I'm going to go Open. And I want to go and find out where this part is at. Okay, so obviously I'm going to go to PC, right? And then to Downloads. And this is not the one I want here. Or is it? No, that's IPT. That's the one I did earlier. Hang on just a second. Mr. Morris always forgets. When we download this, PC, Windows. Let me write this down so Mr. Morris doesn't forget my path there. PC, Windows, users, my name, and then downloads. That's where it says it's at. Okay. All right. So there is my IGES file that I saved from McMaster-Carr. That's the folder it's in. So I got to make sure when I'm in Inventor, that's where I'm going to pick it up. All right. So I got to go to this PC, right? And then come down here to Windows. All right. And then go to Users. And then go to Morris E. That's me. And then we're going to go to Downloads. And here is that's the IPT file. What we have to do is come down here and we have to select IGES right there. IGES file. And this is the one I downloaded just a few minutes ago, right here. So click on this. And it's going to load it into Inventor. And I'm going to go ahead and the object filters, leave solids checked, leave surfaces checked. I'm going to leave all that checked, just like OK. All right, now this is an image of the screw, right? But this is not what I want either, okay? So what I'm going to do is come over here to the browser, and I'm going to expand where it says origin. No, not origin, but right here. Sorry, the check mark. Right-click on this and turn off the translucent option. And now you can see that we actually have a screw with threads cut into it, okay? You can make threads on an Inventor drawing or Inventor part, but it's not easy to do. You have to use the coil function to do that. It shows you threads. It shows you a simplified representation of threads, but it doesn't show you a detailed version of threads. Now, I have this. I'm going to go to File, and I'm going to export this here, use CAD format, and I'm just going to call this screw on a Morse dash screw dash, okay, Morse screw. All right, come down here and we're going to select it as STL file right here. All right, so that's the name of my file name here, Morse screw STL. Save. Okay, I'm going to close this out. Now, Mr. Morris does not have GrabCAD or Catalyst downloaded on the computer that I have at home. I do have it downloaded at the school. So what you can do is you can try now to bring in your file. If you downloaded GrabCAD or Catalyst at home, try to bring in that file. What I'm going to do is see if I can bring in the STL file in here. So there's IGES. I'm going to come down here and I'm going to select STL right here and see if I can open this up. See if it's going to do that. It looks like it's thinking. We'll see if it opens it up. Hang on just a second. Okay, it's really weird looking. I don't know what that's going to give us, if anything. It does appear to give us the threads, though. as well as the socket. Okay, so the only true test is when we print this out, what it's going to give us. So it's not really advisable to download an STL file into Inventor. If I had GrabCAD or Catalyst, you could load this in, and you should do that. Okay. So one more time, here are the steps that you want to do. You want to go on the internet. You want to go to the McMaster-Carr website, and you want to find a part. There's lots of parts that have CAD data in McMaster-Carr. I chose a bolt, but you could choose a sprocket, maybe a gear, or some other component like that, maybe even a bearing. And what you have to do, though, is you have to save it as an IGES file, IGES. Sometimes it's just IGS, so you may see it either way. So save it as an IGS file, okay? And save it to your directory that you're familiar with, all right? And then you can close out the McMaster-Carr catalog, and then you can go open up Inventor. When you go into Inventor, you're going to open up the IGES file. Okay, you're going to open up the IGES file. And like I did in this video, I converted the IGES file to an IPT file, Inventor part file. And then you should probably save it as an IPT. Once you get an IPT, you can then open that file back up, or it might still be open, and you can save as an STL file. Then once you save an STL file, you can then open it up into GrabCAD or Catalyst, depending on which one you have downloaded at home. If you don't have either one downloaded, that's okay. It would be neat to print one out at the school, and perhaps even a nut, a hexagonal nut to go with it, and see how good the fit is. Now, we may have to put this in a solution of sodium hydroxide, which basically dissolves the support structure, okay, which is used as the screw is being 3D printed. The support structure supports it. You have a model material and you have a support material. When you put it in the sodium hydroxide, it basically dissolves the support structure. And then later on, you get it out and clean it off, and you have your part file, or your actual physical part, rather. And then it would be neat to try this with a nut and see how good it fits. It may not fit at all, but when you try to create threads like this, it's not easy to do with Inventor. A lot of times it just uses a simplified version of threads because it's a standard part. Usually threads are associated with a standard part. Not always. It could be a custom-made part, in which case you'd have to make the threads on the lathe. But anyway, I hope that makes sense. I will actually write this down in the instructions, and this will serve as this week's module. Hope you're doing good, and I guess I will see you, as long as the weather holds out and doesn't get too bad for Tuesday. I will see you in class at 2 o'clock on Tuesday to do some lab work. Okay? So we'll have to work together to get our lab back in shape. And anyway, I'll see you then. Take care. Bye-bye.